Hello everybody and welcome back. So in this video we're going to look at the Lewis structures of radicals. We're going to consider radicals like NO3 minus, CO3 2 minus, and again some positive radicals like NH4 plus. Now there's some radicals that do not straightly follow these rules, and we're going to look at them separately in other videos. But let's consider these ones first. I think these ones are very straightforward. Now, before I continue, I would like to show you that, in the last video, I didn't talk about triple bond. I only talk about double bond. So we can actually have triple bond as well. So let's consider CO and HCN, carbon 2 oxide and hydrogen cyanide. Now, if you want to draw for this, let's see how its Lewis structure will look. So carbon has 4 valence electrons and oxygen has just 6 valence electrons. So the total electron that we have here is 10 valence electron. That's the first step. The total electrons, you calculate them. Then the second step is that you have to draw the skeletal structure. The skeletal structure will just be to place them side by side. Okay, and according to the rule, after you place them side by side, you have to add one pair of electron, a pair of electron between the two of them to form a bond. Then you now arrange the remaining electron around them side by, you arrange the remaining electron, you give them the remaining electron to complete their octet. And if you want to do that, you start from the most electronegative element first. So if you check the periodic table, electronegativity increases across the period and decreases down the group. So carbon and oxygen, they are in the same period. Okay, that means, and how do I know? Carbon has 2 shells, 2, 4. Oxygen equally has 2 shells, 2, 6. So they have the same number of shells, so which means they belong to the same period. So also, since they are in the same period, it means this one ends with 4 and this one ends with 6. So it means oxygen is far to the right than carbon, and electronegativity increases across the period. So it means that the one that is far to the right will have higher electronegativity value. So which means that oxygen is more electronegative than carbon. So we're going to fill the electron. We're going to give oxygen the electron first before moving to carbon. So after you've removed 2 electrons, the remaining electron becomes 8 electrons now. So you now have to start from here, 2, 2, 2. If you see for this, it has completed its octet. So the remaining 2, you add it to the carbon. So after the addition, you now count for the 2 of them. If you count for the first one, oxygen has completed, but for carbon, it has not completed its own shell. As you can see, it has just 4 electrons, and it's supposed to have 8. So we know what to do. So we are going to remove 2 electrons from the one that has completed the octet. You use it to form a bond between the 2 of them. So that's the next step to do now. So, and if you do that, you're going to have C. Okay, it will still have its, non-bonding electrons there, but now we are going to have new 2 electrons from this oxygen and the remaining 2 that was there before. Now this is now forming a double bond. Now don't forget, anytime you are removing an electron from the one that has completed its octet to form a bond, it will still obey its octet because you will still count it together with it again for it. So oxygen still obeys the octet A. It has 8 electrons. But if you count for carbon, it has still not obeyed because it's having just 2, 4, 6 electrons. So it has just 6 electrons, right? So now you still have to repeat the same step because our aim, we have not achieved our aim. The aim is to complete the octet for the 2 of them. So you still have to remove 1 more electron from the one that has completed the octet, use it to form a bond again. So when you do that, all you have is C. Okay, you have this that we had before, then you have another one. Okay, oxygen. Now have 2 here. Don't forget the 2 on carbon as well. So if you count for the 2 of them, if you count for oxygen first, for oxygen, it now has just 1 lone pair electron, a lone pair electron, and it has 3 shared pair electron. Can you see? So together it has 8 electrons now. Now if you count for carbon 2, it has now completed its own octet too. This is 6 and this is 2. So that's how to draw the Lewis structure of CO2. And what this is telling you is that we are going to have triple bond between this carbon and oxygen. So that's the meaning of, because a pair of electron means a single bond. So that's how to draw the structure for that. And as you can see, we have a triple bond. The same thing for hydrogen cyanide too. HCN, we have hydrogen, just one valence electron, carbon we have 4, and nitrogen we have 5. Okay, so the total is now 10. And if you want to draw it, I have told you already that hydrogen will always be at the terminal, the second rule. So hydrogen will always be at the terminal. Okay, now between the carbon and nitrogen, which one will be at the center and which one will be at the terminal? So normally between these two guys, nitrogen should be at the terminal. Okay, this one should be the central atom because it is less electronegative than nitrogen. Nitrogen is far to the right because they are still is the same period, and nitrogen is far to the right than this one. So carbon should be here. Okay, and hydrogen normally will be at the peripheral. Okay, at the terminal. So when you put two electrons for them according to the rule to form a bond between them, then you still have to, okay, you have to give them the remaining electron. So the remaining electron now is 8. So I mean it's not 8. From 10, if you remove 4, that's 6. So you start from nitrogen 2, 2, 2. So as you can see, you have reused all the electrons for nitrogen, so no more electrons. Now if you count for hydrogen, hydrogen has completed, it needs just 2, and for nitrogen as well, it has completed 8. Now for carbon, it has just 4. Okay, and if you look at hydrogen, you cannot remove any electron from it to form a bond there because it has no valence lone pair electron. So the only place you can remove is from this nitrogen. So just remove one. Okay, you have H. So before I go, so you have H, a single bond, carbon, then the 2 electron that you have put, then we have this, then we have H, C. You still have to put another one because if you count for carbon here now, it is still not complete, 8. So you have to move another one from here to form a bond. So if you do that, you have this, and you have nitrogen, and you have this one as well. So this is the level structure of HCN. As you can see, for hydrogen it has completed, for carbon too it has completed 8, and for nitrogen too, if you count, it has completed its shell. So look at that, we have this, so it has completed its shell. So that is how to draw the level structure. And for that case, we have H, single bond C, and triple bond nitrogen with these electrons. So that is the level structure of HCN. Now let us go to the main business. So we want to look at the level structure of radicals. Okay, radicals like NO3 minus, CO2, CO3 2 minus, okay, and NH4 plus. Now let's start with NO3 minus. Now the only difference here is that why we have to consider the level structure of radicals separately is that the way you count the electrons are actually different. Okay, you count them differently. So for radicals, they will have charge. Radicals will have charge. So, and if they have charge, it is telling you something about the electron count. For instance, the first tool is to count the electrons. So nitrogen, and we have 3 oxygen. So for 1 nitrogen, that will be 5, that's the valence. And for 3 oxygen, that will be 3 times 6. So altogether, we're having 18 and we're having 5. Okay. Now this will be the total electron. If you have any negative charge, for negative charge you add that number of negative. So for here we're having just -1, so that will be +1 electron. You have 1. So and here that you're having, so for instance we're having 2 minus. Now we're going to add just 2 to this total number of electrons, and if you're having positive, you subtract. So together we have 24. That's the total electron. So we're going to draw. Now if you check, we have nitrogen, oxygen. So nitrogen comes before oxygen, so it means oxygen is far to the right than nitrogen, and for that case oxygen is more electronegative than nitrogen. So nitrogen is going to be at the center, and we have our oxygens, we have them around it. So that's the rule, and you're going to put a pair of electrons between them to form a bond. That's the second or the third rule. The next rule, Then out of this 24, you have removed 6 to form a bond. So the remaining will be 18. So yeah, you start filling them from the one that is more electronegative. So those are the oxygen. So I make sure you complete the octet of the first one before you move to the next one. So 6 here, another 6 here, 6 here again to complete it because it's 18. So we give them 6 here. You move to the next one, another 6, another 6. So that's altogether 18. So all of them have completed, I mean the oxygens, they have completed their shells. Okay, if you count, they have completed their shells. So the next thing is to check for nitrogen. Of course, nitrogen has not completed its shell. Okay, it has not completed its shell. So it means that we have to move one electron from the one that has completed its shell. I mean a pair of electrons. So if you move from this oxygen to form a bond here, we're going to have double bond in that place. So we're going to have oxygen, okay, nitrogen, oxygen, okay, and we have moved one electron, we have another one here, so we have oxygen remaining just 2 electrons. For this oxygen 2, it has completed its shell, and for the nitrogen 2, it has completed its shell. If you count, you see that this is now it. So and if you want to put bond, you just have nitrogen, so a single bond to that oxygen with 6 electrons or 3 lone pairs of electrons. Now we're having double bonds here, so we have that and we have this, then we have this. Okay, so we have this like this. So this is the Lewis structure of NO3 minus. Okay, now you can ask question that why is it that we are removing the electron from the right hand side? We can equally remove it from here to form a bond between the two of them. In that case, we are going to have the double bond up here and single bond here, single bond here. We can equally remove it from here too. We are going to have nitrogen, oxygen, oxygen, and double bond oxygen. Okay, so these are the 3 Lewis structures of NO3 minus. So that's the meaning of, Lewis structure, and they are also called the resonance form. So this is the resonance form of NO3 minus. So this is one resonance form, this is another resonance form, this is another resonance form. So you have like 3 resonance structures now. So let's move to the other one. The other one is CO3 minus. So CO3 minus. Okay, so for CO3 minus, CO32 minus. For CO2 minus, we have carbon and 3 oxygen. So carbon and 3 oxygen. So the first carbon is 4. And don't forget, we are counting the valence electrons, and we have 3 times 6. So that would be, now we're having 2 electrons, that would be plus 2 electrons because you're having 2 minus A. So that altogether will be 4 plus 18 plus 2. So that will be 24. So carbon and oxygen is more electronegative. So oxygen is going to be at the terminal, and we have 3 of them. Okay, so we have 3 of them. Then you have to put the bond, the shared pair between them. Okay, then after that, you have used 6. So when you remove 6 from 24, we have 18 left. So you give them 6 from 18, that remains 12. Still complete this one too. 6, another one, so that remains 6. Then you use the remaining 6 to complete the last oxygen. Don't forget, these oxygens has completed their octet. Only the carbon has not completed its octet. So all you just have to do here is to shift electron from one, okay, of the complete oxygen, or you use the other one. So if you don't shift from here, you can shift from here as well, you can shift from here as well. So you can also have 3 canonical form for that, or the resonance form. So we have C double bond. If I shift for the one up here, one of it here, so you have just 2 lone pair of electron for that, and we have this one remaining the same thing. Okay, and for the last one as well, this is what we are going to have. Okay, and that structure will be C double bond O, single bond oxygen, another single bond oxygen. Then you put their lone pairs of electrons. So as we have it here, we have just 2 lone pair up here, and we have 3 lone pair around these ones too. So this is the CO3 2 minus molecule. And for the last one, which is NH4, for NH4, nitrogen is 5, hydrogen is, we have 4 of that, so it's 1 normally, so we're having 4, that's going to be 4. Then it's having plus, so that would be -1. If you're having plus, if you have 2 plus, that would be -2, like that. So if you're having 1 plus, that would be -1. So altogether this is going to be 8 electrons. So you have nitrogen. Don't forget, hydrogen will always be at the terminal, so that's why we are going to have something like this. So and since we have 8 electrons, just have to fill it between them. 1, 2, 3, 4. Altogether we have used the 8 electrons. So no one to fill the remaining 2. Of course, hydrogen cannot take anything, and in fact we don't even have any electron left. So this is going to be the structure of NH4 plus. All right. So and if you count for hydrogen, they have completed 2, 2, and for nitrogen 2, 8. So that's how to draw the Lewis structure of these radicals. Don't forget, the only thing that will be different there is that you have to subtract when you have positive, and if you have negative, you have to add. So that's just the only difference. So thanks for watching, and I do appreciate you. Please make sure you subscribe to this channel and like the videos. Thanks for watching. And if you want to join our online tutorial, you can just, down here, down the screen by the left hand, by the bottom, left corner of this screen. Okay, so left down corner, so you would see our number there, so you can just message that number to register for any tutorial of your choice. Thanks for watching.